the possibilities of intersection of research approaches. We have great three presenters, and the first presentation would be delivered by Artyom Oganov. He's the Scultech professor. He's the participant of European Academy and the member of Royal Chemical Society and resident of American Physical Society. We see your presentation, so please, dear friends, thank you very much for presenting me and offering me the invitation. I think that the examples which I plan to show in my presentation will show the extent to which it is important for people from the art sphere and scientists to work alongside one another and represent the world by different means, yet understanding the common ground. So let me share a couple of stories and highlight that many technologies which we create and many discoveries which we make were foreseen by the artists, sculptors, and sometimes even composers. Perhaps even poets had the insight. They had the revelation about the atomic structure of the matter. Yet many of the discoveries were foreseen by the living organisms, and that is something that I would dwell on in my presentation. So let me tell you a story of the interconnection of the living organisms with symmetry and the symmetry of the materials. We do know that the majority of hard bodies are of the crystallic nature. There are monocrystals, there are single crystals, and then there are polycrystals. Every crystal has a great majority of atoms, and there is a pattern. There are patterns. There are patterns which look as if the wallpaper, and there's a parallelepiped which structures and tiles the crystal, making a beautiful, ideal. There's a beautiful structure to it. What we're now seeing is the sodium carbonate. Well, the pattern is a part of the culture. One can see it in the mechanic vases. One can look at the Asher paintings and see the patterns. But there's a great majority and diversity of beautiful patterns in the artworks from Iran. We see a tombstone from the northwestern Iran, and we see the repetitiveness. This periodicality affects the symmetry of the crystal. Not every type of the symmetry can be compatible, can formulate the fractal structure. So for example, here we see the triple symmetry within the tourmaline. We see the quadruple symmetry with the Vesuvian, but we see that the quintuple symmetry doesn't work within the limits of the existing math. And the quintuple symmetry, nevertheless, is very popular. So, for example, there is the icosahedric symmetry, which can be seen in the structure of the AIDS virus. One can also look at the starfish and see that there is a symmetry of the fifth order, the quintuple symmetry. Why is that so, that the quintuple symmetry is that frequently seen in living organisms? And in this case, we would have to revert to the writing of Nikolai Belov, who suggested that the quintuple symmetry was a way of battling for one's existence. So, for example, viruses, it is debated whether viruses are living organisms or not, but he suggests that the viruses found this opportunity of having a structure which differentiates virus from the crystal and which helps the living organism to distinguish itself from the unlikely nature of becoming mineralized. This hypothesis was never tested properly, but I find it very elegant. That back in 1984, Don Schechtman found the objects which have a very dense structure, but nevertheless they have the quintuple symmetry. He actually found the symmetry of the 10th order within the object. And so it happened that there is an alloy which is somehow structured not in a symmetrical order. And that was a great surprise. How is it possible to have the orderly structure which has on inside of it many strongly dispositioned atoms? But there is a way of structuring the matter this way, and this is a so-called Penrose mosaic. There are two types of relations between the points of the matter, and these are thick and thin types, which are represented with the irregular numbers. And following the Penrose mosaic, this fake crystal is structured in accordance with this Penrose mosaic.
Опубликовал статью лишь в 1984 году. Но в конце концов он был удостоен Нобелевской премии по химии.
Nevertheless, his finding was debunked, but he was finally awarded the Nobel Award in Chemistry in 1984. There is a lovely short movie, animated short dedicated to quasi-crystal, but I would like to talk more about the connection with art and math. Let us look at the Penrose mosaic. It has two types. It has two types of rhombus within, and to the left you see Roger Penrose, and he stands on the floor, which is structured alongside his mosaic. And he developed this mosaic 8 years before the actual finding of the quasi-crystal. So he had this feeling of the structure before it was found in an actual world. And he was lucky enough to create a patent to his finding so that he can work with it commercially. And he was able to sue Clinics company, which was creating the toilet paper with his mosaic. That's an interesting idea because we usually represent mathematicians as people with a very hazy mind when they have to deal with an actual world. but he was lucky enough to sue Kleenex for using his mosaic, and he won. And you can read the court hearings dedicated to this case, and these are quite interesting. Penrose lawyer addressing the court said that Roger Penrose has his heart broken because Kleenex took his great discovery and made their clients wipe their asses with his beautiful finding. And he won the court hearing, the proceedings. But actually, he had to fail because back in the 90s, it was actually revealed that 800 years before Penrose, Iranian artists managed to uncover Penrose's mosaic. There are periodical patterns, and then there are quasi-periodical patterns, which are actually equal to Penrose mosaic. And there is a so-called Blue Tower in Iran, and there are patterns which date back to 1063. And I guess that this is a great example of the interconnection of art and science. Kolmogorov, a great mathematician, used to say that if you have a beautiful result, please publish it, because it would be of use sometime later. For sure, there would be a part of the science, a branch of the science, a field which would put it to use. And here is an example of it. Artists were able to find the solution, and then mathematician Penrose was able to deduce it mathematically, and then we found an actual representation in the world. And I find it a beautiful history. And you can see how artists forecast the actual work of the mathematician who actually forecasts the work of physics. Here comes another pattern from Alhambra, and they use the symmetry of the eighth order. And there are plenty of examples like this, like that one. And I once was walking around Ismahana Mosque and taking pictures of the symmetry. There are many interesting ideas connected to the Penrose mosaic. When Penrose found that Iranian artists used his mosaic, and when he realized that there are quasi-crystals which use this type of symmetry, he was fascinated because he said that he never felt that nature may be able to devise such a symmetry. And for example, there's a way of making the Penrose mosaic by yourself. You got to structure the rhombuses, putting one to another, and you got to color the structure so that the color would not be interrupted. And you may be able to put the mosaic tile by tile. But there would come a moment when you reach the dead end. There would be a moment where the rules no longer can be applied so that you can continue developing the mosaic. But somehow nature enables the creation of prolonged Penrose's mosaics. And that is a great fascination. And I would now talk more about the life in crystals, but I would try to keep it short. And let me talk about this picture. What you're now looking at, the fish scales. And fish scales look as an armor, but as if it has been done, as if it is made of metal. There is no metal here. There is a so-called photonic crystal within it. And structures of that type work as the mirror. And it may be possible to use an almost 100 refraction of the light. And structures of that type, which have photonic crystals, are quite efficient in the light refraction. And now I'll pose a question. Who was the person who was able to discover the solar batteries? If you dig deep into the history, you may see that the first one who understood how to translate solar energy into the electric energy was the Alexander Becquerel. Then there were several scientists in the late 19th and early 20th centuries, and they were creating the solar battery prototypes. That was Charles Fritz, one of those scientists. And only in the middle of the 20th century, we had the actual and somewhat efficient solar batteries, which use the silicon. And these are, let's say, the grandparents of the actual solar batteries right now. And so the question, who made this discovery, is a debatable one. And if you read literature, you may come back to the 19th century or to the middle of the 20th century. So there is this gap in time for history of the solar batteries. But it happens so that solar batteries are of quite an ancient lineage. In 2010, Israeli scientists found out that the solar battery was developed and discovered by the so-called Eastern Oriental Hornet. Does develop the xanthopterine, and East Oriental Hornet is not like the average hornet. Average hornets sleep in the daytime and are active in the nighttime. An Oriental hornet sleeps when there is a night and is quite active when the sun is out. And the higher solar activity is, the more active Oriental hornet is. And scientists decided to understand why is that so. And they started studying the Oriental hornet, and they realized that the structure of Oriental hornet's body has xanthopterine, which is a solar battery transforming the solar energy into the actual energy. And that is a great discovery made by nature and then made by the actual humans. So there are only two types of solar batteries as of now. It is either Oriental hornet or the man. So we spoke about the photonic crystals, and that is the periodical structuring of materials which have differing refracting possibilities. And the first one to research it was Lord Rayleigh. He was an amateur scientist who was quite lucky to have a lot of money, and he worked for quite some time in Cambridge Library. but he had many illnesses and it was not quite comfortable for him to visit university. So he was writing mostly from his house, from his manor, and he was researching things which were not a part of the scientific mainstream of the time. He was studying the butterfly wings, he was researching gas in the air, and that was not the mainstream, but his researchers led to the appearances of new research fields in biology, chemistry, and other sciences. And in 1997, he was studying the photonic crystals. And it took another 100 years for Sajiv and Giblanovich to publish their seminal work of photonic crystals. So you see the periodical distribution of matters with differing optical possibilities, which enable, like, if we talk, the classic crystals refract the light, whereas photonic crystals diffract the actual light. You can see the representation of it. So if we look at the butterfly wings look that bright because they diffract light at the very certain wavelength. And if you make the wings bigger, you would have the whole rainbow spectrum on the wings. And one is also able to achieve the white light. And we are able to see photonic crystals in the living nature and the non-living nature. And we can see, for example, if we look at the opal, we see that opal is structured with photonic crystals. And the periodic distribution of guanine in the chameleon's skin helps one to change the color. And this effect, engineers and artists from South Korea try to use this natural device from chameleon to transform the t-shirts so that you apply some pressure or crumple the t-shirt so it changes the color. And there is also a line of research connected to the transformation of the car's color in the same line. And that is quite an interesting line of work, because this periodic distribution is also creating the mirroring layer deep inside the eyes of the cats and the deep sea fish. So when the light travels all the way through the eye of the cat and the fish, light travels back to retina and then goes outside of the eye. And this diffraction happens within Xander's eye, and light passes through retina, and then the light wave hits the mirror layer and then refracts back. And our Israeli colleagues, my Israeli colleagues, using the methods of mine, were able to find that Xander's eyes have the crystals which work the same way as the xanthopterin. And you see that there is an enormous field of research open for artists and biologists and physicists. So what was my take on this? I have told you several stories about the same discoveries which are being discovered and rediscovered by people from the art sphere, from biology, physics, and the living nature itself, which have inhabited the planet way before us and were able to make the greatest discoveries, which are now in the heart of the matter of the most developed scientific disciplines. This is it. Thank you for your attention.
Спасибо вам за замечательную лекцию.
Thank you for the beautiful presentation, Artem Romaevich. We would be happy to take questions. So, dear colleagues and friends, do you have any questions? Okay, so we have a question.
Да, Артем, это Гриша. Да, спасибо большое за выступление.
Thank you for your presentation. And I have a question. How were you able to, so you work in the field of chemistry and you work with the design, material design. So why and how did you become interested in this connection between art and sciences? And how can one put this to use? And how can one put this to use within the field of natural science, the hard sciences you do? Yeah. Yeah, just trying to be academical. Yeah, I was not able to see you because the Zoom window is very small. Well, frankly, one can see that in biographies of great artists and scientists that they were interested in research areas of one another. For example, Salvador Dali has been reading the popular scientific magazines and the way he diluted and eschewed the time, or the way he was using pixels. I was in a Dali museum and the tour guide was talking about the way Dali worked with optics and the experiments with the perception of an image, both with an eye and the brain. That is one line of work, but it works in a two-directed way. For example, Mendeleev was a great lover of art, and he was meeting artists all the time. Einstein spoke to many artists, and I feel that this is important to do that. I see that. Let me give you perhaps an example that is quite orthogonal to what I've said. I know many scientists who are doing poetry. I haven't read great poems by scientists. Mostly poems are dull, and my hypothesis is the following. Scientists spend their life studying. We're studying every single day of our professional career, and we're training ourselves to use the correct logic from A to B to B to C to C to D. Whereas people who work in art, they try to train the revelatory skills. They're jumping from A to Z. They're moving from third dimension to the fifth. And we saw that in quasi-crystals. They were able to have such a vision. So my hypothesis is that the artist's point of view is incredibly important because they're able to make the jump cuts, to forego the actual logic, whereas we as scientists are not able to follow the intuition. And I guess that there's a complementary way of two approaches. And I feel that this is important for artists and scientists to mingle and to work together. That's my thinking. Thank you very much. Dear colleagues, do you have perhaps any other questions? Thank you for an interesting presentation. I have a rather personal question dedicated to your taste. So you spoke about varying ways of making discoveries. So we have the non-organic matter, which is able to select things for itself. Then there's the organic matter, which transforms itself through the evolution. Then there's the artist's vision, who's following the schema. Then there is the structured mind of the scientists. And which of that approaches do you find more inspiring? I would rather say that all these approaches can exist. I myself am a scientist. Therefore, I'm more in favor of scientific approach. But when I saw the Iranian artists, when I saw this revelation, I am just baffled by this discovery. Each and every one of us has one's own path. I'm not able to write poems. I am not aware of the jump cuts, and I'm happy for those who can. So let all the flowers bloom. Yes, yes, definitely. Well, speaking about all the flowers, there's an explanation, which I cannot actually test, but if you were able to see the pattern, all the quasi-crystal structures were in iron, in Muslim Spain, Alhambra, and then there is Uzbekistan. I've actually seen something in one Armenian monastery, but I do not quite recall the pattern, but it was quite close to the quasi-crystal. But all those patterns come from the Muslim countries. Why is that so? And I do think that one cannot represent animals and men visually. And artists who were not able to follow the actual representation, Islamic artists started to create patterns. And every time a human being is doing something, one is striving for the complexity. So therefore, Iranian artists were achieving such great and fascinating results. This would be my take on this. Thank you very much. And intuitively, you have almost foreseen my question and had this thinking, and just a fascinating presentation. And yes, the way, as soon as you ban the visual representation of the human being, you're opening another line of thinking. Because if we look at the Vitruvian man, we see the classic representation of the proportions and the human body geometry and scalability. And I myself work with comparative literature, and I write on Gogol. And for example, if one reads Mirgorod, it is the collection of novellas. And the cycle has two parts. Every novella has two parts. Then he has created the collection of stories Arabesque, and he was trying to restructure. He was foregoing, he was crashing all the logical principles behind his work. And literature scholars were not able to understand what was he doing. That's an interesting finding. Sorry, that's just a commentary. It's just, I'm very touched by your findings. Thank you very much. And my question was, but I had a question, but you presented an answer to it, so. There was a question from Nikolai Zorin from Kazan University. A pleasure to meet you. So, dear colleagues, are there any other questions? So let us thank our honorable presenter again. Thank you, Artem. And let us move to presentation from Viktor Andreevich Natochenko. He's a professor. He's the director of the Research Center of the Chemical Physics in Russian Academy of Sciences. And his presentation is dedicated to the innovative laser technologies used for research and preservation of the cultural heritage, monuments of the cultural heritage, artifacts. I'm thankful to, I'm happy to be here, and my presentation is dedicated to the new master program, which connects So we have the new master program, which we initiated with the Tretyakov Gallery, and I would try to talk about our involvement in the world of fine arts. So there's a great question. So there are people who work in the preservation of the cultural heritage, and how and why can we be of use to those people in the fine arts? And I would start with a story of Van Meegeren. There was a revelation in 1945. That was the time when there was a Nuremberg trial. And you see our hero. There is a painting called Young Christ. And Meegeren was dubbed the collaborationist, that he was selling Vermeer to the Reichsmarshal. And the artist said that I haven't sold the actual painting. The truth was that Vermeer that he didn't have any paintings connected to faith. And the hero of this story researched the techniques and styles of old masters from old Dutch masters, and he understood that the work the Christ in Emmaus was labeled as Vermeer's work. Sorry, let me trace back. Something is not quite right. I'm sorry. Can you please put me back to the third slide? So he was selling the artworks. So he was accused of selling paintings to Herring. And while Herring was preparing for the Nuremberg trial, and when he was reading the newspaper, Herring was reading the newspaper dedicated to the story, Herring said, "Oh, it seems that there are no longer good people remaining here." But anyhow, Van Meegeren was able to state that he was forging the painting. And the moment, and so while in court, he painted the painting in the style of Vermeer, and thus the charges were dropped. He sold the painting, but he didn't sell the heritage. And also, you see Elmire de Hori, he was also known as Louis Kassu, Dori Butan, Elmire Herzog. He was also the Count Elmire Hoffmann. And for 30 years, he was crafting beautiful paintings, which were not the actual copies. He was working in the style of other artists. He was copying Modigliani's style, Chagall's style, and there were certain tricks through use of which he legalized the paintings. The thing is that this story with the high art has a backside, and that is connected to the market estimate of the works. Well, this may not be the height of the highest art. It is rather the question of big money. That is a very complex dialectics of good and bad and original and forged works. And I would refer to the beautiful story, which is How to Steal a Million. And there's Charles Bonnet. And there was a story of him making a beautiful statue, which was presented in a museum, and Audrey Hepburn was playing his daughter, and Peter O'Toole was playing the detective. And so Charles Bonnet said, you can use all sorts of methods to study the sculpture. You can use the X-rays, you can do whatever. And that is exactly the moment where one has to have a toolbox, one has to understand the materials, one has to mix the natural history and the provenance. What's the complexity here? And tool-wise, from the chemical side of the question, all the materials used vary quite a lot. And the materials cannot be reproduced. That is quite another problem. And here's the issue of restoration, because when one tries to restore the work, and so, for example, we have, when, for example, we decide to restore an old man and we're able to have a young man, that is unacceptable. As our colleagues state, one should never repaint something the painter has done. And here comes the question on how can we use our methods? How can we use the methods from the natural sciences?
Направления, связанные с применением лазерных технологий в работе с
There's a certain field of work connected to the laser technologies, and it is an avant-garde of actual research. And I decided to take a great publication which brings together the community of scientists working with laser, and they had an issue dedicated to focus on cultural heritage. And the main tool we have is the light. There are many light sources in the nature, and we can use. We can, for example, have the synchrotron. We have a couple in Russia. One is in Grenoble. But laser is cheaper. It is rather available, and it is a very successful field. We can use the UV lights. We can use the infrared emission, irradiation. We can have there are many options and variants which we can use. And lasers are usually used for cleansing. There are classic ways of cleaning the picture with chemical materials or mechanical tools. And I've seen the way the restorers work in Tretyakov Gallery, and that is a very precise, and I would rather say, it all works with emotions and insights, and you would see that in the next presentation. But there are methods which give great results. One can use the laser to clean the stone. Europe and Italy are using the laser, and you may see the way the stones in urban space are being cleansed. Researcher picks a laser, decides on the wavelength and the wave width, bandwidth. You see that every type of laser is attuned to a specific task and a very specific result, and it hinges on the decisions carried out by the restorer. And this laser cleaning, we cannot say that it is omnipresent. Well, that's not quite it. So let me show you the work of one of our students.
И вы видите, что здесь 4 пятна. Эти 4 пятна, которые очищены, они совершенно разные.
So our student was working with a canvas, and one had to clean the canvas. And you see 4 blots, and you see the way the cleaning works, and the cleaning works differently. He was applying differing lasers, and one doesn't stop at the cleaning because experts would address us and ask us, what have you done? Haven't you burned our piece of heritage? And here we use other methods. We use the compensation scattering, and we use the feedback control. We use the beacon, which serves rather as a fingerprint. And you can add other methods. Here's another work from another student of ours, and she was working with lasers as well. And she was using the Romanov spectroscopy. And we worked alongside one another, trying to combine the pigments so that we would be able to see the admixtures, to see the impurities. And we use the Raman scattering, creating the structures which were not affecting the objects and which were empowering the lasers. And in order to analyze this mixture of data, it is increasingly important to understand the mathematical methods. And the mathematics we use is called chemometry, and we use big data. Here's another way which gives us in situ and information about the object. It is so-called laser-induced breakdown spectroscopy. And the idea behind it is quite simple. So there is a laser spark which hits an object. We see the light of the plasma, and the plasma light is detected. And then, in accordance with specific lines, you look inside the spectrum and you evaluate what is the object of your research and what were the transformations of this object. And that is a quite productive method, mostly used with metals, with stones, and materials of that kind. And there are more subtle methods. For example, the objects which we work with, and mostly these are pigments. We have a new method, FLIM, and this is the transposition of the method from life sciences into the heritage preservation. Researchers used it to work around the biological objects, and we're measuring the spectrum and we're measuring the intensity on each and every luminescence. And we're also analyzing the life cycle of this luminescence. And this analysis of the life cycle enables us to see something that it cannot be caught by the human eye, and that gives us more data. Here comes another method, which is being transposed from biology. And the method is that is a non-reversive technology. So for example, when we work with lasers, we are influencing and in a sense harming the object. Whereas in this case, we use the interferometer, and we see the structure of our object we see the in-depth structure, we see every layer on the canvas without affecting the work itself. There's another great method created by our professor Litochov, and this is the photoacoustic spectroscopy. Here we use the laser light source so that our complex object laser is being consumed. A laser creates an acoustic wavelength. This acoustic wave is being registered, and you see the ultrasound representation. But unlike the ultrasound, which we have in medical work, here we can work with a very small scale objects. And through the use of the photoacoustic spectroscopy, one may use the representation. One may see the representation of the sketch on the canvas. And this is type of information is one cannot see through the human eye. So that was my small presentation on how we can slightly help people with restoring the cultural heritage. And this is it. Thank you very much. Okay, the microphone works. Thank you very much. That is an interesting presentation. And I myself, as a person who constantly works with the attribution of the artworks, primarily fine arts, I have a question as to how those technologies help to make it possible to trace a specific composition of the pigments or the mixtures used by the specific artist. I know that, for example, in Europe, when people work with old masters, for example, Vermeer, or Impressionists, or Van Gogh, using this subtle chemical and physical analysis, scientists reveal the mixtures which one can use to analyze the percentage of the organic attribution to the very specific master, because now we know that forgery is almost the next level. People can use very old canvases. Forgers are able to mimic the works of 19th century, mimicking, for example, unknown Scandinavian artists. Therefore, my question is, do we Russians have something like that? I think that we do not have questions like the credibility or the authenticity of Vermeer, but do we have something like that?
Да. Это будет зависеть от того, сколько стоит.
It would rather depend on the budget of the research, but one has to understand that the type of chosen method, I was talking about the spectral methods, there's got to be a great dimension. It gives you an opportunity to see the fingerprints. And the fingerprint has to be interpreted by the appropriate experts. So it is a reciprocal connection. We ourselves, within our laboratory, we would look smart enough, but not useful enough. We have to work jointly with colleagues from the art historians. And you have given a couple of great examples, and that is a separate line of work. Because there are definitely forgers who may be able to recreate Van Gogh in a quite original style. Whereas here, reciprocity is the key to the work we do. And there's an issue of intuition, the talent, the providence, a very specific assemblage of skills of the master. Are we able to recreate it fully? I highly doubt it. Because there is a question to how the artist mixed the materials. What was the thinking behind it? And I feel that in every single next work, there were alterations. So I feel that an important addition would be that physical sciences and chemical sciences can be of help in we're able to gather and produce objective data. We can, to a certain extent, interpret the data, but our interpretation would be, quite frankly, limited. And if we take restorers separately, they have their own limitations coming from their method, but there would appear something in between. And I myself think that art historians are the ones to carry out the final judgment. I would add here that as of now, art historians are those who come to the specific conclusions, because the art historian works with the heritage and is legally responsible for it. Yeah, you know, there are so many publicly existing forgeries which are published in catalogs. Let me add here, one can say that there's an echo of artworks, because forgery can be quite genius, almost as genius as the original artwork. One cannot do that in maths. We are studying Pythagoras in school, but we're not becoming Pythagoras. Whereas here, a person may be able to research the technique and the style of the master and imitate the master. But there's definitely a line in which you become secondary. Yeah, let us come back to spectroscopy, but Pythagoras is a great example because you work around, because art historian works around the task at hand, and the experimental methods are there to achieve this task at hand. And I know that this research is expensive, just as artworks are. And the creation of causation between the objective data and the somewhat mathematical task at hand of the art historian is quite the way. Let me add here that this task is to be carried out together I would say here that art historian should doubt our methods, and we should doubt the conclusions of the art historian. And you have marked the expensive nature of our research. And the word technologies makes sense here because technologies make it cheaper for us to use now, because lasers which costed at about $1,000 10 years ago are more available now. Thank you very much. And I myself am no art historian or physicist or the chemist, but I'm quite interested in seeing how organic and non-organic matter are put into the analysis. So do you see the biological cycles? Do you see the specifics? Because I know from the history of... Yeah, I understand your question. And here we are at the frontier of the modern science. There's a certain matter which was like half an hour ago, we spoke about the lac. We spoke about the varnish, and there are certain specific characteristics to it. It transforms over the time. It gets oxidized, etc., etc. And we use the aging chamber, and we recreate the life cycle of the matter, and then we compare this data to the existing data. But that's an enormous knowledge base. Well, yes. Thank you. Thank you very much. Dear colleagues, I would rather say that Tatiana Yurievna Lastova is connected to the artist's works, and she oversees a department in one of our top-ranked universities. So, any other questions? Can you please say what are the perspectives for the genetic research of the pigment components? We can use not just the spectral analysis, but we can use the biological data. Yes, when we talk biology, we talk lasers as well, but there's another problem. But there is the biodegradation of the artifacts. Bacteria, fungi are everywhere. And bacteria exist mostly as the biofilm, and bacteria keep on chewing on our precious artifacts. And that's not just a question of diagnostics. It is a question of how to battle this biofilm, and we do not have explicit knowledge, do not have it enough. Thank you. Dear colleagues, are there any other questions at hand? So there are no questions.
Спасибо. Друзья, мы переходим к следующему, заключительному.
Dear friends, we now move to the final presentation of our session.
Доклад представят наши коллеги из
And we have colleagues from the State Tretyakov Gallery, and they represent the Department of Complex Research, and they're actual researchers. And complexity here comes from using both the art methods and methods from the natural sciences. And we have Julian Halturin. He oversees the department. It is a very serious presentation. And the co-presenter is Yulia Diakonova. And she's the senior researcher at the department. And they are talking about the very actual problem they managed to solve this very year, and that is the restoration of Ilya Repin's masterpiece, Ivan the Terrible, and his son, the Ivan. But I give floor to the colleagues. So dear colleagues, it is a pleasure to address you, and I'm happy to follow the session and follow the discussion, and it is quite informal. And I'm happy that presenters, that there is more room for us to present, and I would like to follow up in the steps of Viktor Andreevich, and I would like to comment one of the last questions, which was dedicated to the aging of materials. That is, frankly, a big problem, which is called the degradation of the pigment, and it is known for many years. And I feel that even those who are not connected to the issues of the practice of restoration or research do know this material which is used commonly, and that is the asphalt. And originally, asphalt is the resin which was used by many artists, and they knew that this resin dries out quite slowly. And given the technical advances they had at the time, they were looking into ways to solve this problem. And that is one of the examples. And there is a vast majority of the examples. But the issue here is the problem at hand is that we cannot model properly and therefore find a proper way to counteract this degradation or even replace the materials properly. That would be the commentary. And if you have any questions at hand, we'd be happy to address it. But coming back to the presentation of ours, I do feel, and we asked for a bigger time slot, because the world of natural sciences and the museum world, we do not have that many crossroads. And that is something Andrei addressed it in his brilliant lecture. And the research is perhaps one of the rare points where we intersect. And we call it the technical research in our museum world. And that is a question for the museum laboratory. And Yulia Diakonova and I, we represent the lab of ours. And I would like to say that in our country and in the world, the museum laboratories that have enough of the research material are quite scarce. We have the Hermitage, we have the Russian State Museum, and we have our gallery, and that is it. And the department of ours, which presents this presentation, we have chemists, we have X-ray specialists, we have photographers, we have art historians, people coming from very differing professional backgrounds. And we have people who work within the framework of natural science, and we have people who work within the framework of art history and theory. And this combination, which is hard for us to handle sometimes, this combination creates the interfering, cross-directed, interdirected data analysis, which gives us an opportunity to research the material features of the art. And that is the task which we have. And I would like to highlight it again. We are not restoring, we are researching the material nature of the cultural heritage. And if we talk about this point of view, there are many tasks we have, and that's a wide-ranging spectrum of issues. That is the correct date, and many museums and many monuments require the date, the dating, the reconstruction of the life cycle of the monument, the research of the materials, the research of styles, etc., etc., etc. And the presentation of ours does include not only the history, the 4-year-long history of the restoration and the research of the masterpiece, which was attacked in 2018, but it also highlights the direction into which museum evolves today. That is a wide network of international contacts. That is the usage of the most contemporary technologies available. That is the work alongside the scientists. And these are the newest methods which we try to work, and a very conservative approach, which is do not harm. And now I would like to give floor to Yulia, and we have 2 parts in our presentation. And the first part, Yulia Borisovna is going to deliver. 25th May of 2018 in Tretyakov Gallery. Oh, thank you. Okay. I'm sorry, nothing happens. So, May 25th, in Rabin Hall in Tretyakov Gallery, there was an attack on one of the most known works of Rabin, Ivan the Terrible, and his son Ivan, November 16th, 1581. One of the visitors took the medal and attacked the painting, and the painting was attacked with a knife 100 years ago before. And the art history knows only 2 attempts, 2 times when the work has been affected several times and yet sustained. And this is The Night Watch by Rembrandt. Rembrandt painted the painting in 1885 and showed it at the Peredvizhniki exhibition, and it was fiercely debated. But the friends and co-workers of Rapin were unilateral in thinking that this is one of the greatest work of his. And Adrian Plahov said that the tragic terror of this intensity was not seen, not in just in Russian, but in international art as well. End of quote. The narrative chosen by Repin addresses one of the most tragic pages of Russian history. Tsar kills his son, and there's brutality, there's violence, there's unabashed and unlimited power questioned in this work. And this painting was censored, and it was not to be seen, and it was forbidden to take photographs of the work back in the times. In 1913, Abram Balashov visited the Tretyakov Gallery, and he attacked the painting, and he cut it with a knife 3 times. And he was yelling, "That's too much blood, too much blood." And he was attacking the face of Ivan the Terrible and his disciple. But what helped to sustain and maintain the integrity of the work was the stretcher. But if one does the X-ray of the painting, one sees the cuts. And the painting was restored in 1.5 months. And the canvas, the original canvas was replaced. The cuts were sealed. There were atonements made. And there was a priming. And Repin, who was 68 at the time, was restoring the painting again, and he reworked the cuts. In 1922, the painting was affected again. During the autumn rains, the heating system of the gallery was affected, and the humidity rise was noted. Painting was presented under the glass at the time, but in 1924, the restorers saw that the layers started to disassemble, and everybody thought that the transition happening within the work was connected to the larger social context. And in 1939, there were more dissolutions of the layer. And the issue was with the disconnection of the priming and the colored layers. And that was one of the issues at hand, which was there before the attack. You see the orange dots, and these are the points of the disassemblement of the layers. In 1945, the painting, alongside other works of Tretyakov Gallery, were moved to Novosibirsk. And that was the only time the piece traveled outside the gallery. And the restorers has created a special construction with 2 shields which preserved the eel painting. After the piece traveled back from Novosibirsk, restorers kept observing the painting, and they were working with a partial restoration of the layers. And the painting was not presented at the exhibitions so that it wouldn't further disassemble. Next slide, please. Right after the attack of 2018, the piece was severely damaged. The canvas was attacked in 3 points. And yet again, the shield stopped the metal column and stopped the vibration. But there was the glass, and the shattered glass affected the canvas as well. throughout almost 100 years. I'm sorry. So throughout the 100 years, restorers had this issue of the detachment, of the exfoliation of the color. And they had their own hypothesis, but they had a limited amount of tools. And they tried to sustain the painting for as much as possible. And they hoped that upcoming generations of restorers would be able to use the more contemporary technologies for the analysis. So, in a certain way, the attack made restorers incredibly responsible not only to fix the tragedy, but also solve the complex issue of the general overall illness of the painting. So that was a historical brief of the project which we have undertaken, which we managed to achieve only in 2022. By the spring of this year, and we have publicly presented the results of the restoration. And we would have another slide dedicated to this presentation. And now we come to the second part of the presentation, which is dedicated to the research program of ours. And the goals which we had are formulated as seen on the screen. I would say that
перечисленные на экране пункты. Ну, наверное, как в любом...
That the work we have undertaken exceeds the bullet points you see on screen. Just as in every scientific work, we felt that we are together the vast spectrum of materials, and then we had to correct the data, and the restorers kept on having questions, and we have been merging data. And people think that scientific methods are of use only in the academic science. But here I can clearly state that we use the methods ourselves, just as people do in other academic institutions. Right from the very start, we decided that the work would be conducted within the gallery. But we kept on working with professionals from other institutions, and we worked alongside other researchers, and it affected our work, and it affected our approach to restoration. And I would perhaps like to extend the thank yous to everyone involved in this particularly complex project. Further on, we will talk about the methods we used, and we were looking for the most optimal ones. And the museum lab has been restaffed, both in terms of technical equipment, and in terms of human resources. So, for example, we use 5 methods of chemical analyses, 5 types of analysis, including chemical analysis, hygroscopy, X-ray analysis. So we made a huge leap forward. Perhaps I have to say that museum is not a research institution. Therefore, when we use the methods, when we buy equipment, we try to keep it practical. There are plenty of restrictions. We're not able to make big probes and to test big areas of the work which are required for the chemical analysis, because it is forbidden, because all the rules of handling the artworks forbid such a move. So therefore, we try to work with academic institutions by using the optimal minimum of tools which we can host in our lab. So first and foremost, we researched the surface of the painting in order to check the damages of the colored line, and we created the cartogram which had to be there, so that researchers and restorers plan the work ahead. And the problem was that the shattered glass left cuts and bruises on the canvas. And there was a great issue of distinguishing the author's work, the author's cracks. So we were forbidden to move the painting. We could have only moved the painting after making this cartography, which was shown on the previous slide. And we had to take pictures of the painting, and we did the infrared representation, and we used the ultraviolet scanning, which helped us to trace the preliminary sketch of the work. And preliminary sketch is important for seeing the details obscured by the time, and whereas infrared enables us to see the provenance. It was important for us to deliver the panoramic radiography. And so the painting is 2 meters on 2 meters. And so we had to make 87 separate shots. Well, if you may have been in hospitals, so you have the X-ray list, which was scanned properly and added to the panoramic view. And I would say that we are perhaps the only museum in Russia which can perform such a task, because it requires a lot of resources. But in terms of information, this information enables one to get much more information than in just taking the picture. But it's also important that radiography gave us a chance to check the canvas and see the micro cuts. In order to analyze the components, we used the spectral methods. We created the micro radiofluorescent analysis, and that gave us a chance to analyze the palettes. And this is a non-invasive method. We're not sampling the piece, which is of utmost importance for the museum practice. And that is a world as international approach as we can get. Every chemical research starts with the micro radiofluorescent analysis. We use the RTEX equipment from Brooker company. I wouldn't delve into the modes of picturing. You can read it from the slide. There was a second important method of the infrared spectroscopy, and that gave us a chance to learn more about the master's varnish. It required sampling, and the sampling we did, and the sample is less than a millimeter. And there are specific museum protocols for carrying out such work. And if one is sampling the face, the scene part of the work, one has to consult with restorers. So that is a very meticulous work. And using the infrared spectroscopy, we were able to understand the classes and the units. We were able to learn more about the polishing and the materials which were used at the time of the restoration. Because we know that every 100 years there were restorations, and we were using, again, Brooker's equipment. And we were also using the compensatory scattering of the Raman's spectroscopy. We were using the same samples taken for the infrared spectroscopy. And this method enabled us to test and clarify the results taken by the previous tools. And we did this research using the Raman module developed by Thermo Scientific. And that was a testing method. And we like it very much that we have this apparatuses.
Искусства существует ряд трудностей. Например, лазер часто жжет эти пробы безвозвратно.
But there are complexities with using the samples because almost every time sample is affected and burned by the laser. And in a way, every piece of a painting is sort of a Russian doll. Because if we talk about the fine arts, it is a layer connected to the layer, connected to the layer, and every layer within itself is a complex composition. Therefore, the Raman method leads to certain complexities. Can we move to the next slide, please? And let us overview the results. So we used the Acoustics methodics for the analysis of the ortho canvas. And I would say that spectroscopy played a great deal. Sorry, it was the polarizing microscopy. And we were using the lambda filter. and we were able to distinguish between the types of fiber used in the author canvas and the doubling canvas, which was attached after the first attack in 1922. And we saw that the fiber is of matching origin, and the linen canvas is the most sustainable and is the most widely used and also the most most expensive canvas in the fine arts, because the linen fiber is the most durable. It is expensive, but useful. And there's the author canvas. The fiber is structured differently, not that eloquently, that the doubling canvas, and that may have affected the structure of the painting. And here's a simple example. Every one of us has a pair of jeans, and we wash jeans, and every time you wash jeans, they lose shape and then they take shape back. Same happens to the canvas with an artwork. So for example, if we have the interconnection of two canvases which were constructed differently, that means they have a differing degree of tightness. And that was not taken into account in 1922, or perhaps it was overlooked for reasons unknown. It is 1913. It is also important to note that the canvases were connected with a glue. And there was a carbohydrate noted in this glue. And there was also a casein. So that was a glue with organic additions. And there is a so-called Sturgeon Glue. And the Sturgeon Glue is very susceptible to humidity. And as we were researching, the painting grounds, we saw that there are mercurial whitewash and the fats which were usually used at the time. And we should note that the ground in this work has a very tight layer. Even the cuts were not affecting the tightness of the ground. So here's the list of pigments we noted, and you can read it. And I would say that as we were looking into the connecting elements, we realized that wrapping was following the tradition of the oil painting. And we saw the addition of natural resins. And that means that perhaps Repin was adding the varnish. And that is a very traditional practice, especially for the classical techniques of the fine art. And many samples gave traces of the lead salts, and you see how it is seen visually. And there's a zinc stearate, one can actually see it on the surface of the artwork without using the spectroscopy. And you see the white mass coming from the craquelure. And white lead and zinc lead was used in this work. And we suppose that Ilya Repin was using linen oil because we saw the fatty acids, and we see the volume, and we see that this white mass, this is the fatty acids turning into the lead salt, and those aggregates accumulate over the course of time and may lead to the appearance of craquelure and pushing the acids to the surface of the painting. And the research concluding the work was compared to other researchers of other Repin's work. It is important that we use the very same toolbox and the very same amount of technical devices to run this comparison. And that gave us a tremendously important comparative material. And so we understood that Repin was mostly using canvases with a pre-existing white oil ground. And that type of ground was very popular in the second half of 19th century, both in Russia and in Europe. And we know that Repin was buying his canvases in Germany, so it is of European descent. And there was a limitation for using this ground. But the problem was that this type of ground was not remarkable for its pulling qualities, stretching qualities. And because of this lack of stretching, ground was not fully connected to the color. And therefore, artists had all types of techniques to balance it. And they were, for example, rubbing the ground with penza. And that was a way of fine-tuning the oil ground in order to provide the durability of the artwork. And here I would have to note that ground of whichever type and colors of whichever type has its features and its bugs. And it is important to find and strike the balance. And here, I would like to say that this was not just the artist's mistake, rather it is a combination of factors. And there was this effect. And we also found the stable palette and the stable combination of pigments, and we can have a conclusion, and we can see the choices of materials made by Repin, and we saw that he worked traditionally and that he didn't apply anything that could have affected and could have caused the illness of the painting. And apart from the researches that we done, and there were certain stages to our additional research. We were removing the glue applied by the author in 1983, because the glue was moving inside the linen, and the full removal of the glue may have affected the stretching, and so restorers were not able to work with water solutions because the Sturgeon glue is very sensitive to water. Therefore, we had to look for the non-standard measures, and that is looking into ways of using the laser technologies. And our previous presenter was addressing this very issue. And the laser technologies were used for the controllable removal of several layers of the glue. And this very method proved its efficiency, but it had to be corrected, and we had to adjust the parameters. If the task was not that responsible and not that complex, we can even say that this is a funny situation with the tests which we have. These tests gave a fantastic result because the fiber was cleansed and there was no glue there. But we realized that it is not right to clean the fiber to the fullness, because the glue and the fiber has now already created a new composition and redistribution of way of the colors on the painting. And the parallel research we had, we decided to cleanse the structure of the painting differently. There was another research connected to comparison of the adhesive materials which could have been used in order to strengthen and fortify the layers. And we were looking into historical materials such as Sturgeon Glue, Venetian turpentine, and we were looking into contemporary adhesives as well. And we ran two separate researchers, one led by Viktor Ivanovich in MIPT, and we worked with the National Institute for Restorations, and we were researching the applied usage of the mixtures, and we were looking into the consequences, and we created two groups of prototypes which went through the aging process, and we were analyzing the chemical characteristics, chemical features, and we were testing the sensibility of the adhesive materials to the corrosion. And the Federal Biotechnological Research Center has conducted this research, and we have concluded that synthetic adhesives, paraloids and plexisol, have proven its work. Finally, through the careful analysis of the restoring protocols from the 20th century, we saw that the varnish was put, that the varnish was fortifying the painting, and the previous restorers were not removing the restored materials, and that affected the work, because with every next layer there was the more uneven distribution of color on the painting, and that led to the varnish becoming a burden affecting the pre-existing illness of the painting. And therefore our restorers thinned the existing layer of the varnish.
Справа у себя на экране подтверждали правильность такой операции. Один из таких образцов, представленный на слайде, показал присутствие 3 лаковых слоев, толщина которых
And one of the samples which you see on the slide represents 3 layers of the varnish. And there were moments, there may be the connection of 4 to 5 microns. That is, there is more varnish than the actual colors. And so this operation with us thinning the layer gave us the chance to retrace the original color palette of the work. So summing up the project, Rembrandt was very particular in searching for the colors and palettes. Therefore, the chronic illness of the painting cannot be attributed to the specific style and method of Rembrandt. And we feel that the issue comes from the combination of the factors, that is, the doubling of the canvas in 1913, which happened after the first assault, the usage of the differing fiber may have affected the distribution of weight and the distribution of layers of the painting. The additional effect was caused by the Sturgeon Glue, which has connected to the doubling canvas. Then it is the lead salts, which is a universal problem which affects all the oil paintings. These aggregates appear in all the cases. And that is the issue which is tackled only now. And this mechanism of working around the oil is not clear enough. And there was the surge of humidity in 1942, and this humidity spike surge affected the transformation of the painting, and the sum of alterations caused by the restorers throughout the 100 years has quite severely affected the masterpiece, and the understanding of the chronic illness of the work has enriched our understanding of how this chronic illness may have affected the restoration process and vice versa. Can we move to the next slide, please? So it took us 4 years to restore the work as it is. And every next step within the restoration process was taken from the do not harm approach. And then finally, the restoration happened. And as soon as we create the new display case, the piece would come back to the gallery. And here's the traditional slide with all the thank yous. And I would like to say, outline 2 things specifically. Firstly, our colleague, Kirill Shumikhin, who is listed here. He's an actual co-author of the presentation which we gave today. And it is important for us to note it. And I hope that he may be listening to us on Zoom. And I would like to highlight the connection to institutions like the Federal Centrum of the Chemical Physics and all the other institutions with which we worked And we have moved through quite a period through developing this connection, and there's a great potential to our joint work. And this I say both as the researcher and as the director of the department. And the result we achieved, and the result which is as of now represented, and the lines of interconnection of the natural sciences and the contemporary equipment we have, and the museum staff and museum practices, and given the complexity, given the incompatibility of our scientific discourses, given the differing understanding of the causal relations, despite all that, there is a perspective in our joint work. And I'd like to thank you for your patience and for your attention. Dear friends, are there any questions? Thank you very much. I have a short technical question. Why did you use the film? Do you not? What about the photographic detectors? That is a small and technical question, but I can answer for hours. So are you looking for the extremely high definition? Yes. The aim is to have this high definition. There is a cluster of factors. Some of you may not know the questions of the museum radiography. Just so you know,
исследований, применяемый для исследований
radiography is one of the oldest methods used in the history of arts since the beginning of 1920s.
персонажа, о котором Виктор Андреевич рассказывал, Фан Мехерен, там использовалась рентгенография в том числе. Так вот, есть два метода.
And the Van Meckeren, who was presented in the previous presentation, was also analyzed with the radiography. And using the film is always more expensive. There are more expenses, and there is a duration limit for the film. And it's hard, and it's also hard to buy film nowadays. It's harder than it was, yes. And we use different types of the film. So, for example, if you're working with an icon, you may have better results while varying the contrast of the film. And we're going to have a conference dedicated to the restoration, and we're going to discuss it. And the digital photography is cheaper. You're not having to pick the analog materials. But the resolution that you have, the resolution which you get, and the height of this detector, the very technical accessibility of connecting it to the artwork, it's just big. Detector is rather huge. And so the combination of those factors prevents us from the active usage. I would like to say that it's just like using the liquid crystal television. So at the very beginning, the longevity was not good, and they were bumpy and big. And as of now, they look as a sheet of paper. So I hope that serves for an answer. Thank you. Thank you very much. Are there any other questions? Okay, I see this one. Thank you very much for the lecture, for the presentation. I may have missed, and therefore I'm sorry, but were you able to treat this chronic illness of the painting? So would the disassemblage of layers happen again or not? Oh, so you hear me now? Okay. So the answer is, we'd have this answer after a while, because that's what our profession is like. Because we used all the possibilities to test. We used the new methods. We were moving step by step so that we limit the amount of risks we have and to heighten the possibility of arriving at a good result. But nobody can guarantee how the process would unfold. The restorers when the restoration happens, and restorers were proud of saying what they have achieved, and they said that they guarantee the quality, and the museum staff was saying you shouldn't guarantee anything. So time will tell. Can I have a follow-up question connected to the restoration results? So you've shown us fragments in the infrared, and that there is a piece of work which has blackened. So were you able to update the colors so this blackened part of the picture is seen better than it was?
Да, спасибо. Вы не были
Thank you.
участником той пресс-конференции, которая проходила по...
So you haven't been at the press conference we held by the very end? And that was a happy coincidence, because perhaps that was the rare opportunity to see the artwork without protective display or glass. And we have reconstructed the original colors through this thinning of the varnish, because every varnish, just as every type of matter, gets dusty, gets blackened. And so we made the thinnest possible layer of varnish, which brought back the original color features developed by the artist for the work. So as soon as the work comes back at the exhibition, the glass would prevent you from seeing it properly, but we did restore the original colors. Well, just as Yulia Borisovna is quoted, why this Balashov in 1913 attacked the work, shrieking, "There's so much blood," because this is the power of the color. Let me perhaps comment on the question. And for how long this chronic illness has been cured? So the restorer for the piece is pretty much like a surgeon for the actually ill person. So restoration is basically surgeon's work. So in this case, just as in surgeon's work, the quality is maintained through two factors: the art of the surgeon and the tools which were used and the materials which were used. So in this case, this particular case, doctors were of highest class, and they have invited foreign experts as well. And the materials which were used were selected from the widest spectrum, and the adhesive material was chosen and selected from a great number of works from options. And the one was picked which has the best adhesive qualities. So this edition, there is no guarantee here, because one can only guarantee the parameters. So other questions. I have a technical question as well. So Shumichin was running the chemical analysis. What do you mean? Was he running the analysis of the elements, or, well, we were outlining the chemical analysis methods which were used. That is the radiography and fluorescent analysis. That was a colleague of ours. She was working with us at the time. She was using the laboratory equipment Artex. So these were the methods. Yes, exactly. And did you run the elemental analysis? Because there are great tools which can run the elemental analysis on very small samples. Surely, yes, these tools exist, but it was important for us to rather have a general overview, and then through clarifications and the clarifying data from the restoring protocols, sort of shifting it. So, for example, we planned to make photographs. We planned to work with the liquid microsamples, and we were doing that alongside the colleagues. But we were not able to do that strictly because the size of the sample was not allowing us this. We were using the microscopy as well, and that was a subtask of ours. Thank you. Other questions? So we ran out of questions. Dear friends, let's thank the presenters. Dear colleagues, thank you.
Ну, на этом наша
It has been a pleasure.
секция
So
завершена.
we're concluding the session,
Благодарим
and we thank all the participants and listeners for their
и
interest,
желаем всем
and
успехов.
we wish luck to all the participants. Thank you. Thank you, dear colleagues. Thank you for the fantastic, informative presentations, which exist on the intersection of art history. And we had a broadcast, and there are 2 days of the conference ahead. So you can visit our website and you can see the broadcasts and you can see the links. And we have been broadcasting in English on YouTube. And I would like to say that apart from a couple of technical minor glitches, we had everything working and it seems to be there. So if there are any questions, I would be happy to answer it. Thank you very much and thank you for being with us. Bye.